So in case if you don't have or you're not using Google Colab to get the results, again, let's use the code to get the best hyperparameters once the grid search is completed. In our case, we are using Google Colab, so it could present the best, hyperparameters for you here. But in case if you're running on, for example, Jupyter Notebook, you may access or find the best set of hyperparameters using the best params function. Let me just find the best parameters. You can access it by calling and then you call the best. So as you could see that it has returned the same result that has Google Colab has provided to us. So after we say that we run the GridSearchCV with the logistic regression model, we can find the best hyperparameters found during the search by using the best params. As you can see, this will return the best combination of the hyperparameters based on the performance during the cross validation. This means the best regularization string C is equal to 0.20 in our case, and the optimal solver is the linear. Just make sure that your grid search CV has completed fitting before running the best params function attribute. So these are the best params that our grid search CV has found for the logistic regression. Now let's evaluate the performance and see the accuracy on the testing dataset to see whether our model improves, its accuracy improved compared to the baselines that we have or not. To do that, we can, start typing. Let me just add this comment. Evaluate the grid search CV or cross validation for the logistic version model. Simply, we can just, get the score on the X test and Y test datasets. So, okay, dot score on the X test dataset and the Y test dataset. We run this now and see what would be the results. Okay, so 88, or let's say 86. I don't think so that we have a huge improvement compared to the baselines that we have. If you recall that our baseline for our logistic regression was almost the same thing. So even though that we are doing some, hyperparameter tuning, it seems that for the logistic regression, this is the best, uh, you know, results that we could get, even though that we tried to do a grid search CV. We have also evaluated the grid search, CV for the logistic regression model. After we fine-tuned it, we found the best parameters. So this means that the logistic regression model based on the hyperparameters found by the GridSearchCV has an accuracy with an 88 or 89% on the testing data. This implies that the model correctly predicted the target variable. In our case, if you recall that our target variable was whether a patient has heart disease or not by around 89%, which we can also consider the test data as unseen data. Now, after we have tuned our logistic regression using the grid search CV, and the result was the same with the results of um, around 89 compared to the baseline model, unfortunately, we are unable to see any big difference when tuning the logistic regression using the both of the random search classifier method, neither the grid search CV. Just to summarize the grid search CV compared to the randomized search CV. So to start with the randomized search CV, let's take it on. I had just a small table here that summarizes both of the grid search CV methods and the randomized search CV. So the randomized search CV, it takes like a random sampling. It randomly samples a fixed number of the hyperparameter combinations from the search space. It's faster and more efficient and computationally less expensive, especially for large, continuous parameter space. And it's less exhaustive, like may miss the absolute best combination, but can still find a good hyperparameters quickly. So it does not go to each of the parameters, find the best parameters, and it asks you to apply these parameters compared to the grid search CV. So the grid search CV goes through like an exhaustive search. It evaluates um, so it evaluates all of the possible combination of the hyperparameters in a predefined grid. If you recall that one time when we were doing the grid search CV, we found that there might be 100 combination, and that is a very huge number compared to the randomized search CV, which just find you the best parameters and you can apply it, compared to the grid search CV. So as I mentioned, it evaluates all of the possible combination of the hyperparameters in the predefined grid. Also, it's computationally like expensive, which can become slow and resource intensive as the search space increases. Think of like exponential growth, but it has like a guaranteed optimally ensures finding the best combination of the hyperparameters within the grid. So these are the main differences between both of the grid search CV and randomized search CV. So when to use each of them? So to use randomized search CV when you have a large hyperparameter space, okay? Again, when should we use the randomized search CV? When you have a large hyperparameter space and trying every combination would be computationally expensive or time consuming. If you don't have the time and computational resources, then it's the best to go with randomized search CV. Also, when you are not sure which range of hyperparameters to focus on and want to explore more broadly, as well as if you want to get good enough hyperparameters quickly, focus about quickly without spending a lot of computational time, then go again with the randomized search CV. On the other hand, when to use like grid search CV? So to use grid search CV, if you have small hyperparameter space and you want, exhaustively explore all of the best combination. GridSearchCV will find you the best combination between all of these, hyperparameters. And also, if you want to guarantee finding the best set of hyperparameters in your defined grid, accuracy and performance are critical in case if you've been asked to have very, accurate results, and your randomized search CV hasn't given you the accuracy that you're looking for. So grid search CV, when it searches and find the best combination of all of these hyperparameters, it's ensuring the accuracy and performance, which is very critical if you have a case with a critical requirement for the accuracy and you can afford the computational expenses and resources, and you have the enough time to find the grid search CV, or to use the grid search CV, considering the time and the resources that you're running into. So that's all for using the three methods that we tried to do to hypertune our models. We tried the grid search CV, and we tried even the randomized search CV. Also, we tried to hypertune our models by hand for the KNN model. So this is the summary of this section.